Okay, so in this problem we have the tank in the shape of an inverted circular cone with height 10 feet and base radius 4 feet. Okay, in this one we're saying that it's only filled with water to a height of 8 feet. So if you look here, this is what it looks like. So what I'm going to do now is I'm going to create the region which when rotated about the y-axis will give me the right circular cone. So I'm going to put, so looking at this, you can see that it's going to be a line like this, and a y-axis and a horizontal line, a region which when rotated will give me that right circular cone. So this isn't to scale, but it gives you some idea. And so we're talking, you guys, about this particular region. So now looking at this, we know that the radius of the base is 4 feet. So x is 4, and we know the height of that is 10. So if you can picture, when we rotate this about the y-axis, we are getting this right circular cone. So now our main step in this is going to be, we are going to subdivide from 0 to 10 into n subintervals, and we will put the typical rectangle. So we're going to rotate that rectangle about the y-axis, and we have a right circular cylinder. So looking at this, this will be the radius of my right circular cylinder. And of course, everybody, what is the height of that going to be? It's going to be delta y. Okay, so I know that my v sub I is going to be pi r squared, and then the height is delta y. So I now have to figure out what r is. So if everyone notices, what is r? R is just x. It's really your x sub I. So r will be your x sub I. And so now I need the equation of this line. First I have to find y in terms of x and then solve for x. Okay, so now we are going to get the equation of that line. So several ways of doing it. We can go y equals slope x plus the y-intercept. The slope, one way of doing slope is to say it's up 10, so it's the rise over run. So it's up 10 over 4, which reduces to 5/2. And the y-intercept is where it intersects the y-axis, which is at 0. So this equation is y equals 5/2 x plus 0. So now I'm going to solve for x, and I'm going to write it as x equals 2/5 y. That's because we're going to want the x sub I. So now we can put down what v sub I is. V sub I equals pi r, which is the x sub I squared, and the height is delta y. But v sub I is pi, x sub I is now the x of that equation, so it's 2/5 y sub I squared delta y. We now have v sub I. Now the next thing we need is d sub I. That's the distance that we are going to move that slice of liquid to the top. So can everybody see the distance will be d sub I is right here. So thinking upper minus lower, upper is 10, lower is y sub I, that distance becomes 10 minus y sub I. So now we're ready to get work. Work, W sub I, is density times volume times d sub I. Well, the density of water is 62.5. V sub I is pi 2/5 y sub I squared. We're going to have the delta y, but then the d sub I is 10 minus y sub I. Okay, so now based on this, you guys, we now have the integral. So work integral is the integral 62.5 pi 2/5 y squared 10 minus y, and the delta y becomes a dy. Now the only thing we have to worry about is what the limits of integration are. We started at 0, but let's go back for a minute, and if we go back to the problem, we see that it said it was filled with water to a height of 8 feet. And so when we go back down here, this upper limit will be 8. And this is the work needed to empty the tank.